Hey everyone, welcome back, and today let's solve Leetcode problem 2657 titled Find the Prefix Common Array of Two Arrays. So we're given two zero-indexed integer permutations, a and b, both of length n. And a prefix common array of a and b is an array C, such that C at index I is equal to the count of numbers that are present at or before the index I in both a and b. And we need to simply return the prefix common array of our two input arrays a and b. I'll refer to them as array 1 and array 2 for simplicity and readability for our solution. And in fact, even in my editor, I actually changed a and b, the two parameters, to actually be array 1 and array 2, just to make it a little bit easier to understand. So a sequence of n integers is defined to be called a permutation if it contains all of the integers from 1 to n exactly once. So in example 1, we have our input array A to be 1, 3, 2, 4, and our input array B to be 3, 1, 2, 4. In this case, our resulting output would be of length n, in this case of length 4, the same length as A and B, or array 1 and array 2. And the reason why we have 0, 2, 3, 4 for the 0th, 1st, 2nd, and 3rd indices correspondingly, because, first of all, 4I equals 0 at the 0th index of this resulting array. We don't have any number that are common between our input arrays, array 1 and array 2. And so C at that index, or C at index 0, would simply be 0. We don't have any common numbers. However, at I equals 1, so at the first index now, we see that both 1 and this 3 are common up until that index in both the arrays, array 1 and array 2. And so C at index 1 would then be 2. And then at I equals 2, at the second index, we see that 1, 2, and 3 are all common at that index up until that index in both the arrays, and so C at index 2 would then be the number of common elements, 3. And finally, of course, at the end or the last indices of both of these arrays, obviously they're going to contain all the characters correspondingly at the last index, and so that's going to be equal to 4. All of the elements 1, 2, 3, and 4 are all common in every single, or rather in both of the input arrays, because it is the last index that we're considering. That's the reason why our output array is going to be 0, 2, 3, 4 at their corresponding indices. In example 2, we have our input array 1 and our input array 2 to be 2, 3, 1, and 3, 1, 2. And in this case, our output is going to be 0, 1, and 3. At I equals 0, we don't have any common numbers. 2 is not common to 3. Those are the only two values up until that 0th index, and so we have it C at index 0 to be 0. At index 1, we only have one common element. That is that 3 that's shared up until that index for both of the arrays. And so 3 is going to be one element, and so C at index 1 would be 1. And finally, C at index 2 would be 3, because all of the elements would then be common. We have access to all of the elements from both the arrays in that range of 1 to n. And so in that case, we have the final index value to be simply 3. It's going to be n, the length of the inputs A and B, or array 1 and array 2. Right, 1, 2, and 3 are all common in A and B up until that last index, and so C at index 2 would simply be 3. So we see that the length of A and B are always going to be equal, and that's also going to be denoted as n, which is always going to be less than or equal to 50, and any index I in the input array A and B is never going to exceed n. And it is guaranteed that both A and B are both a permutation of n integers, which is good because we're always guaranteed that we're going to have valid inputs, and we don't have to have any weird edge cases where we don't have values in that corresponding range from 1 to n. So with the problem statement examples and constraints out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so what is one very, very important observation that we can really make to really help us lead to our solution? Well, basically, if we really examine a prefix of length k, right, k is simply just an input sample, let's just say here, really, the common elements between array 1 and array 2 are only going to depend on whether the elements at the same index in the two arrays are the same, as well as the elements that we've already seen in the prefixes, right? So basically the way we're going to really approach this problem is we'll use a counter, or a hash map, I guess, in Python, to basically keep track of the common elements that we've encountered so far up until that index or iteration. And we can also use a hash map or a dictionary basically to store the frequency of every single element encountered in those two arrays as we iterate over them. And finally, that resulting array, which is simply going to store the number of common elements for every single prefix length, right? For every single index or value in that range from 1 to n, for basically, again, every single prefix length there is. Right, so for a high-level rundown of the idea, basically we're going to iterate through both the arrays simultaneously. They are actually going to be the same length, we're guaranteed that, and we're also going to simultaneously maintain a count of elements that we've seen so far up until that index in each array. And for every single index, we're simply going to count how many of the common elements from the current prefix we actually saw in both the arrays, their corresponding counts from our counter hash map. So with the high-level rundown out of the way, let's go ahead and dive straight into the code here. So first of all, I'm going to initialize my common list. This is literally it's going to have length n. It's going to be the common characters up until every single index of length n. And so this is effectively what I'm going to be returning. It's my resulting common list. And I'm also going to initialize my count or counter to be that hash map or dictionary, right? Basically, what we're really doing here, to reiterate, common is basically going to store our result. It's going to hold the number of common elements for every single prefix of both the arrays. And this count hash map or dictionary, if you will, is basically going to be used to store the frequency of every single element that we've encountered so far from both the arrays. Okay, so now let's actually start iterating over our array. Doesn't really matter which length we go over. We can either go for I in the range of array 1, of length of array 1, or array 2. It doesn't really matter because, of course, they are going to both have the same length. So we're just iterating over n times over the number of elements that each of the arrays have, right? Basically, I is the current index, right? So in this, for every single iteration in this for loop here, we want to increment count at array at I. So basically, at the current element, that should be 1. So we want to basically increment count at the first array at that index, basically that current element, to be equal to count.get, the get method, basically its value at the current indice of array 1, passing in a default value of 0 if it's not a key in the hash map, and we're going to add 1 to it. Technically, we could use a default dict here, but I kind of wanted to keep it a little bit more straightforward. I didn't want to have a default dictionary as I felt that would be a little bit too advanced. And we're going to do the same exact thing for count at array at 2. It's going to be equal to its current value, so it's .get, key value pair of array at 2. But in this case, we're going to pass in as well a default parameter of 0 and increment its corresponding value if it is in the parameter or hash map by 1. Right? So very, very similar structure here, but it is very important to really understand what this really does here. Basically, we're updating the count dictionary at the current element from both of the arrays, right? For every single element in the array 1, we're incrementing its frequency by 1. And this get method, what it really does from the count hash map, it basically ensures that if the element is not already in the dictionary, we start off with a default count or key value pair of 0 as the second parameter before actually adding 1 to its current frequency that is in the current hash map. Right? And very similar to the previous line, we're simply updating the count dictionary on line 7 for every single element in each iteration at index I in array 2, which will make sure that we keep track of both arrays' elements as we actually progress through them up until every single index I. Okay? So, once we've actually kind of initialized that hash map as such, or really, I should say, build up that hash map in every single iteration, we want to then get a common count. This common count is going to be the common count of characters up until this index I, right? It's going to store the number of common elements between the current prefixes of array 1 and array 2 up until this index I or iteration, right? So once we actually initialize that common count, let's actually iterate over our count hash map once we've actually done updating it by this iteration. So for every key and value here, unpacking in Python, in count.items or count.all values, right? Again, this is unpacking. We know that every single thing is going to have exactly 2 parameters, or as such 2 variables linked to each other. We're going to have a key mapped to a key value pair. So we're just unpacking where the key is the current key and the value is the current key value pair, right? Again, iterating through all the items in the count dictionary. Or again, to reiterate, to better explain it, the key is the current element and the value is how many times the element has appeared across both prefixes of the arrays up until this index I, right? We're iterating through all the items as a key value pair unpacking in Python. Now, for every single value and key in this iteration of all the different items in the count hash map, if the current value that we're iterating over, if it's actually greater than 1, if it exceeds 1, well then we can increment our common count by 1 as well. And what that really means here is basically on line 10, I don't care if the current value is 1. Well, the reason why this is so important is because we're checking if the current element, if it's actually appeared more than once. And what that really means is it's common to both array 1 and array 2 up until the current index if it is. So if the value is greater than 1, we have found a common element, and so we can then increment our common count by 1, because that means the element is common, meaning it appeared in both the arrays up until this point, and so we can accordingly increment our common count. And once we've actually incremented that common count, we want to then add it. So common.append the common count. Right? Very important here. Basically, after we check all of the elements in the count dictionary for the current prefix, we're simply appending the common count to the common list, which is going to keep track of the number of common elements for every single prefix of length k per se up until that index I. Okay? Sorry, this should be unindented because we do this once this for loop, or rather, once this nested for loop is done executing, once we've actually kind of built up our hash map and iterated through all the key value pairs and incremented our common count accordingly. Okay? So once we've actually appended the common count to the common list, we simply have to return that common list once it's actually done being executed, because of course this would contain the number of common elements for every single prefix of the two arrays up until every single index I, right? So as you can see, if I were to submit this right now, unless I made any syntax errors, either should be accepted and should be a valid solution. Okay, sorry. This should be array 1. Sorry about that, guys. Looks like I, misspelled my error there. This should be I, the current index, that is. Same thing here. Okay. Now there should be an accepted valid solution. Sorry about that error here. Okay. Oh, oops. Exact same mistake here. It should be at array 2. Sorry about that, everyone. Just me completely misspelling it. Now this should be a valid solution and this should be accepted. And as you can see, this is really just about as efficient as you can really get it to be. So for a quick high-level rundown how this code actually works as a whole, basically on a high-level rundown, we're iterating through both the arrays and calculating the number of common elements for every single prefix of the two arrays up until that corresponding index I for each iteration. And basically, for every single index I, we're counting how many elements are actually common between array 1 and array 2 using that count hash map from index 0 to the current index, right? Where the result is basically going to be a list of the number of common elements for every single prefix, and that function is simply going to return that list, this common list that we initialize on line 3. So for the time complexity, this is actually going to have a formal, fully simplified time complexity of big O of n squared in the worst case, where n is the length of the arrays, right? It doesn't really matter which array because they're both of length n. And the reason why is because, of course, the for loop here on line 5, it's going to iterate through every single element in the array once. And within each iteration in this nested loop here that we initialize on line 9, we're actually going to be having a nested loop where we basically check the count dictionary, right? That's going to have a size equal to, worst case, big O of n. But to kind of tie that in to basically how it works, within each iteration, we're checking that count dictionary, and that can have a size equal to the current number of unique elements in the array. And so the overall time complexity is big O of n squared. To kind of reiterate, kind of messed up that explanation, basically, the for loop here iterates through every single element in the array once, or rather both the arrays. Within each iteration of this for loop here that's nested, basically we're checking for the count dictionary in this nested loop here for every single element, and worst case, that is, that's going to have a size equal to the current number of unique elements in the arrays. And so the time complexity is going to be big O of n squared in the worst case. And so for the memory or space complexity, this is actually going to be a big O of n memory complexity, because the space complexity is really just dominated by the size of this count dictionary. That is the main auxiliary memory or extra data structure that we're really using, the bottleneck as such, and that can store up to n elements worst case. And so the overall fully simplified space or memory complexity is going to be a big O of n solution, really just a linear solution, whereas our runtime complexity is actually quadratic in n squared. So if you guys enjoyed the solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.